Hi, everybody. Good morning. Let's see our schedule. So today is Wednesday, May 1st. And today you have homework about session 13.1 and 13.2 due. And this Friday, we have homework 13.3 due. Our final exam is on Monday from 10 to 12 p.m. Yes, 10 to 12 p.m. I have already sent you a calendar invite. Mm-hmm. Right. Let me check. Did I send you a calendar invite? Yes. Okay. I sent you a calendar invite. So, okay. So it's gonna be Monday. And I just give you back the exam. So exam 4, high score is 97. Good job. The lowest is 50, and the average is 81. So your average is much better than the previous exams. We have 2A, 2B, and 1C, and 1F. Okay. So right now, because we have all the chapter exam scores, I hope you can go to my grades. So you can click grades, and then you can see your scores. So if we have the homework assignment, and we drop the two lowest scores. Okay, so you can see your overall homework percentage. If you don't get perfect scores, feel free to come to my office. I'm happy to work with you to uh, get the perfect scores on your homework. And also the self-assessment includes the practice exams. Oh, Will and Brain.
Oh, thank you.
Okay. All right. So yeah, we just talked about you guys do much better on this exam. So the average is 81, and high score is 97. Lowest is 50. Okay, so go to grades, and then you can look at your scores. If you want to improve your homework scores, come to see me. Okay, we can work on the problems. And if you miss some practice exams or exam correction and wrapper, please submit those as soon as possible. By the way, I give you back exam 4, right? You don't need to do exam 4 correction and wrapper because there's only 2 days left. So you don't have to do that one. But the others, okay, let me see where the assignments. The homework assignment, we dropped the 2 lowest homework. If you have been getting perfect scores on your homework, you don't have to submit the last 2. But I hope you do your homework because you want to do well on the final, right? So you need the homework. And the quizzes, we already took all the quizzes. Bless you. Thank you. And self-assessment, yes, make sure check your grade. Did you submit everything? Except the practice final exam is due Sunday. Okay, so our exam is on Monday, right? So the practice final exam is due that Sunday midnight. And so your exam 4, I have already posted the solution. So even though you don't have to submit the exam correction, but I hope you can still look at the solution and figure out your mistake. Okay, so then you can prepare for the final. All right, so I just give you this blank formula sheet, right? So I will give you this formula sheet for the final exam, but it's blank. So you need to be able to memorize all of these, okay? And the answer is right there. So on your 13.3 worksheets. So we have the derivative of the 6 trig functions and the antiderivative, you kind of think backwards, right, everybody? And this is the power function, function, and the logarithm function, and exponential function with a base b.
So you can use this on the final?
Yeah, you can use this in the final, but it's blank.
Yes.
But
yeah.
you kind of can look at this to find the pattern.
Yep.
Yeah. Okay, so any questions so far? Yes.
So all that's going to be for the final two, the sine, cosine, tangent.
Yes. Yeah, your final has everything. But the trig functions is just the last two problems. So thank you. If you look at the practice final exam, it has 12 problems, right? And the last two problems is about the trig. Okay, 12 problems. The last problem is about the trig. Okay, so you have a question about the derivative. You have a question about the antiderivative. And that's it. So yeah, one problem out of 12. Okay. But your actual exam might have less problems. Because do you remember we skipped the application of the mixture problem? Yeah, so you won't have the mixture problems. Okay. So let's see. It's still there. So you just skip that problem. Yeah. Okay.
Oh, this one.
Yes, this one. Yes, this is the mixture problem. Yeah, you can skip this one. Yeah. Okay, so then let's continue. So let's first review all the derivative and antiderivative. Okay, derivative of x to the p is p times x to the p minus 1. But the integral is we add 1 to the exponent and then divided by the new exponent, right? The derivative of ln, absolute value of x, is 1 over x. So integral of 1 over x is ln absolute value of x. The derivative e to the ax is a times e to the ax. But the integral is multiplied by a, we divided by a. And then, b to the x, we multiply by l and b. And then here, we divided by l and b. Okay, everybody? So, the trig function. Remember the two halves, okay? So, the two halves, we have sine and cosine linked together, right? So that the derivative of sine is cosine. And because of chain rule, we multiply by a. And then derivative of tangent. Remember, tangent has two y secant. So the derivative of tangent is secant square. And the chain rule ax prime is a. You multiply by a. Derivative of secant is secant tangent of the same angle. And because of chain rule, we multiply by a. And then the cofunction is negative co of whatever above, right? So the cosine is minus sine, and you multiply by a. The cotangent is minus cosecant squared, you multiply by a. The derivative of cosecant is negative cosecant, cotangent, and you multiply by a. And then this side, you kind of just solve for the cosine. See, you divide it by a, you get integral of cosine is 1 over a sine. And here, integral of sine, you divide it by minus a, so negative 1 over a cosine ax. Oh, okay, attendance. Let's see. And similarly, integral of secant square is tangent. And be careful, sometimes students get confused and we think that the integral of secant square is tangent square. No, it's just tangent. And we don't know what is secant. Okay, so we didn't learn what is the integral of secant. Okay, so that's why if you see secant, there must be something you can simplify. So you get secant square. Integral of secant square is tangent. And then similarly, integral of cosecant square is minus 1 over a cotangent. Integral of secant tangent. See? Integral secant tangent. So, yeah, secant tangent. So don't integrate the secant and integrate the tangent. We don't have the integral of secant. We know the integral of secant square and the integral of secant tangent. Okay, so it must be one of those types. Okay, and also integral of cosecant cotangent is negative 1 over a cosecant ax. Okay, and so we don't know what is the integral of tangent. We don't know. We didn't learn that. Okay, so therefore, make sure you have secant square or secant tangent. Okay, yes. So there must be a way you can simplify your function to get those two. Okay, let's continue. Example 2. We have integral of 15 secant 7x and tangent 7x. In your exams, I realize some of you, when you see something like this, the 15 is a constant multiple. Okay? When you integrate or when you differentiate, constant multiple just stays here. Okay, so C times F prime is C times F prime. So you don't need to do quotient rule or product rule for that. C constant multiple just stays there. And so therefore here, the 15 constant multiple just stay here, right? And then you have secant tangent. What is the integral of secant tangent? What's the integral of secant tangent? Yes, very good. 1 over 7 secant 7x. Right, everybody? So look at this. 1 over 7 is 7 secant 7x. Okay, so that's the first term. The second term minus, do you see 26 is a constant multiple? Just leave it there. Okay, don't do quotient rule or product rule. And in fact, for integral, we don't have product rule or quotient rule. Okay, and integral of cosecant square. What's integral of cosecant square? Yeah, very good. Negative 1 over 3 cotangent 3x plus c. Right, everybody? Mm-hmm. And let's simplify it. So 15 over 7, we group the numbers together. And then, minus become plus. And we get 26 over 3 cotangent 3x plus c. That's it. Right, everybody? Mm-hmm. So we use the formula. Okay. So in the final exam, you can maybe spend 1 or 2 minutes to write out all the formula. And when you solve the problem, you just look at the formula. Mm-hmm. Okay. So any questions about example 2? No? Okay. Let's continue. All right. Example 3. We have integral sine x to the 2/7 cosine x dx. So these formula are the basic formula. Okay? If you see the integral does not look like these, it means you need to do something else. What are the something else? Okay, so besides this formula, we learned two integration techniques. They are the U substitution and the integration by parts. Okay, so when you look at the integral, you check, is this integral one of these formulas? No. Then you have to do something else, something extra, which is either the U substitution or integration by parts. Okay, U substitution. Let's look at this. Oh, do you see that this guy is like a composite function? Is like sine x to the 2/7 cosine x dx. This is like a composite function. So when you see a composite function, you do U substitution. You let U be the inner function. Like this problem, my U is the inner function. So we let U be sine x. What is du? Derivative of sine is cosine x dx. Right, everybody? So now we can plug in everything in terms of U. So integral U to the 2/7. And then, cosine x dx is du. Hey, everybody, when you see a composite function, think about the U. And by the way, no product rule. Okay, so this is not equal to. So sometimes maybe you might want to integrate the sine. Integral of the sine is minus cosine x to the 2/7, and times integral of cosine is sine. No such story. No product rule for integral. Okay, so when you see a product, this is not the same as the integral of this part and times the integral of that part. No such story. So this is a composite function. So U substitution. And this will contribute to the du. Okay, now see, this is our basic formula. What is the integral of that? U to the 9/7 over 9. What do you do to the 7? Move it upstairs, right? And plus C. Good. Finally, what is the U? Sine x. So you can put the 9/7 there and plus C. We solve that problem using U substitution. Everybody? All right. Cosine x is the du. Yeah, so after you plug in the u and the du, you only get integral about the u. And you integrate it, and then you plug in what is u. You see, we actually don't integrate the cosine together. We don't do that. It's the u substitution. That's the du. Okay, everybody? Okay, let's continue. So if we have something like that, what do you think the U should be? Exactly. U is the inner function. So cosine x plus 11, right? And then the du will be, what is the derivative of cosine x? Negative sine x dx. Right, everybody? Okay, let me double check my, okay, the recording is working. Yeah, I remember last class, my recording, sometimes like the screen is not sharing, so they can only hear my voice, not the recording. Okay, so then we plug in. So we have denominator is square root of u, right, everybody? Yeah. Numerator, you see the 7 still here. Okay, 7 is 7. But then the sine x dx, see, sine x dx is the negative du. Okay, so you can put negative du here. So we change everything in terms of u. Okay, so you must either have everything in terms of x or everything in terms of u. You cannot have both, right? Because this is a single integral. It's not a double integral. Yeah, you did double integral. It represents what? The volume, okay? Yeah, the volume on top of a region. So single integral represent the area under a curve. Okay, so we don't want to see both variable in a single integral. Okay, so then let's see. When you see something like this, make sure you get the standard form. Standard form of power function is a number times x to the some power, right? Okay, in this case, what is the number? So we have 7, but negative, right? That's the number. And this is u to the what power? Yes, negative 1/2. Right? We are ready to integrate using the power rule. Constant multiple stays here. The integral of u to the minus 1/2 is 1/2 u to the, do we add or subtract? We integrate. Yeah, then we add 1 to the exponent. Yeah, so u to the 1/2, and then divided by 1/2 is the same as multiply by 2. Okay? Yes. So when you do this problem, you have to be careful. Are you differentiating or are you integrating? The u substitution, the process involves both. Because you have your u, and then you differentiate it to get the du. But after you plug in the u, you integrate. So differentiate and then integrate. So gotta be very careful. So we get 2 times 7 is 14. U is cosine x plus 11 to the 1/2. And then plus c. So far, so good, everybody? Uh-huh. Okay. We keep going. So more u substitution problems. Okay, look at this one. What do you think the u should be? What is the inner function? Exponential function is secant. You see secant of exponential function. Then who's the inner function? Yeah, the e to the 3x is the inner function. So we call this u. Okay, u is the inner function. Okay, and see, this is also u. And after we figure out the u, what is du? Yes, 3 e to the 3x. Everybody? Mhm. And don't forget our baby dx. Because this is a differential form. You must have differential on both sides. Remember, two kids play on the seesaw? Yeah, you have the differential on both sides. And now, do you see our integral? We have e to the 3x and the dx. Together is how many du? Yes, 1/3 du. Everybody? Mm-hmm. So, okay, now we're ready to plug in. We have integral. Do you see e to the 3x? We put it together with the dx. That is 1/3 du. Where do you put the 1/3? Outside. Where do you put the du? At the end. Right, everybody? And don't put your du here and then put the function here. If you put your du here and put the function here, you're just like integrating one du and then you multiply by the function. You're not integrating the function. Okay? So make sure you put the du at the end. Okay, and let's see. So do you have the notes for the previous problem? Yes, okay. And let's see what's inside. We take care of e to the 3x and the dx. That's 1/3 du. What's inside? Secant u tangent u. Yes, secant u times tangent u. So after the u substitution, you should get integral that you have the formula for it. What's integral of secant tangent? Oh, beautiful. Integral of secant ax tangent ax is 1/a secant ax. But in our problem, secant u is like the a is 1. Okay? So integral of secant u tangent u is just secant u. A is not the variable. A is the coefficient of the variable. If you only have u inside, the coefficient is 1. Okay? So be careful. Okay. So we have this is 1/3. After you integrate it, don't put the integral sign anymore. Okay? So integral of that is secant u. And you need to add c, our cell phone. That equals, what is u? Yes, e to the 3x. And then plus c. Okay, everybody? Okay, so this is example 5. Any question up to now? Okay, now it's your turn. Everybody do example 6. It looks like quotient, but do we have quotient rule for integral? No. Think about u substitution. Do you see a constant function or an inner function? By the way, if you want to show me a note for intercredit, feel free to come to my office after class. Yeah. And continue to work on your homework to get perfect scores. Oh, and I also have a study session this Friday afternoon from 3:10 to 5. So feel free to print out your practice exam and work on it. The root. Yes, the root. The root of 3 is the root of cos. Okay, let's check our solutions together. So all of you recognize the u is the inner function, which is inside the direct function, the 2 ln x plus 3. And when you differentiate, the derivative of ln x is 1 over x dx. The derivative of 3 is 0. But then here, our problem, we don't have 2 over x, we have dx over x. So dx over x, both sides divided by 2. We get 1/2 du. So then this guy, the 13 in the denominator is a constant multiple. We can move it in front of the integral. Then we have cosecant u times cotangent u. This is 1/2 du. You can also move the 1/2 in front, outside of the integral. Because the 2 and 13, they're both in the denominator, they become 1/26. And you have integral of cosecant u times cotangent u. This is our antiderivative formula, right? So negative cosecant u. And don't put 1/u, because it's cosecant ax, cotangent ax, integral is 1/a. But in this case, the a is like 1. Okay? A is the coefficient, not the variable. And then finally, you put the u back. Okay, everybody? Good. Okay. So this is the u substitution. And now, let's review integration by parts. Okay? So first thing you do is look at the formula. Does the integral look exactly like these? If not, then either use substitution or integration by parts. Let me remind you, integration by parts. When do you use integration by parts? When you see function looks like x to the a, e to the bx. In this case, you let u be x to the a. And then, so let me also put this here. Then these guy, you let it be dv. Why? Remember integration by parts formula? We have integral u dv is uv minus integral v du. Yes, everybody? U is something you can differentiate and make the problem easier. And v, dv is something you integrate, and the problem is not that hard. When you have power function times exponential function, you let u be the power function. When you take the derivative, do you see your power drop down by 1? So your problem is getting easier. Okay? And you let dv be exponential function. Bless you. The integral is still an exponential function. Okay? So that's why this time we always let u be the power function. And the second type, when you see x to the a times ln bx dx, if you see exponential function, power function times the log, in this case, you always let u be the log, because we only know how to differentiate a log. We don't know how to integrate a log. Okay, everybody? That's why u must be the log. Then the rest is going to be dv. Okay? Today, something new. If you see x to the a times sine bx, or x to the a times cosine bx, you let u be the power function. Okay? Same reason. The derivative of the power function, your degree dropped down by 1. And then your problem get easier because your power function is simpler with degree dropped down by 1. And then the remaining is going to be the dv. So the integral of sine and cosine is just cosine and sine. Okay, so you're not making the problem easier. Harder. Okay, so we always let u be the power. Okay, so you can summarize the pattern is when you see power function times exponential function, log, or sine, cosine. You do integration by parts. And what do you want to let u to be? The first choice, natural log. If you don't see natural log, then the power function. Is that clear, everybody? So only these three types. Okay? Other type of function, don't use integration by part. Maybe use substitution. Maybe you simplify it. Maybe you can cancel something. Okay. All right. Let's see here. Okay. Look at this problem. What do we want to let u to be? Yeah, the 5x. So we let u be the power function, the 5x. And then dv is cosine 4x dx. Right, everybody? Okay, what is du? Yeah, 5 dx. And what is v? What's integral of cosine 4x? Negative or positive? Positive. And 1 over 4 sine 4x. Is everybody okay with that? We integrate the cosine 4x, which is 1 over 4 sine 4x. And now we have the integration by parts formula is what? uv, right? uv, write it down. 5x times 1 over 4 sine 4x minus integral of, bless you, v, write down the v, times du. What is du? 5 dx. Hey, everybody. Let's simplify it. Let's group the numbers together. So we have 5 over 4 x sine 4x. Can we move the number in front? Yep. So 5 over 4 integral of sine 4x. Read the power of the integration by parts. It reduces the power of the power function. Now you get constant times the sine. Do you know the formula of the integral of sine? What's the integral of sine 4x? Plus or minus. Negative, yes. And then? Negative 1 over 4 cosine 4x. Right, everybody? So therefore, this is 5 over 4 x sine 4x. Let's multiply the numbers. What do we get? When we multiply the numbers, we get 5 over 4 times 4, 16 cosine 4x plus c. But this is the indefinite integral. And we're looking for the definite integral, right? So, which means we want to plug in the bounds. Okay, from 0 to pi over a. Okay, which is this guy. Okay, which is this guy. And we evaluate from 0 to pi over 8. Can I write something like that to save space? Okay. So we want to plug in pi over 8 first. Do you agree, everybody? So 5 over 4, x is pi over 8. And then sine 4 times pi over 8. Right? We plug in x is pi over 8. Plus 5 over 16 cosine. By the way, what is 4 times pi over 8? Yeah, pi half. Yes. So this guy is pi half. So this guy is also pi half. Yes, everybody? And then we subtract when you plug in x is 0. Do you see the first term? Next to the x. Or you plug in x is 0, it's gone. Right? So the first term is 0. But the second term is 5 over 16 cosine 0. What's cosine 0? Yeah, 1. And we also have the pi over 2. Look at the sign. What is sine pi over 2? 1. So this is 1. How about cosine pi over 2? 0. This guy is actually 0. So bye, this term is gone. And now we have 5 pi over, what is 4 times 8? 32. And then subtract 5 over 16. This is the final answer. Just leave it like that. Do not need to simplify. Okay? So definite integral is after you find the indefinite integral, then you plug in the facts. Plug in the upper limit of integration, subtract, plug in the lower limit of integration. Okay? So any question about this problem? No? So how about today, let's take a class photo. Okay, let's take a class photo today. And let me start recording.